Hello again. You have made it to the last section of Chapter 1, and this is Section 1.10, and it's density. And density is a really interesting phenomenon. It's what makes us sink or float. And the more dense something is, the more likely it is to sink. It has to be more dense than water, or it will float. And so if you look at this picture here, you'll see that you've got a cork, and if a cork floats, ice actually is less dense than liquid water, and that's why it floats on top in your glass. And metal, aluminum, and lead is really dense. See, woo, it's a lot more dense than everything else. Will sink. That's why they use lead weights when they're fishing, if you've ever wondered. And so objects that float are less dense than water. Objects that sink are more dense than water. So what density is it's a comparison of the mass of something to its volume. And this is something that's like always the same for each material. And so another way of saying the mass compared to its volume is to write it on top of each other, mass over volume. So the density is the mass of an object in grams usually, divided by its volume in either milliliters or cubic centimeters. And remember, 1 milliliter is the same thing as 1 cubic centimeter. So that's why you can use either of those. A lot of times in cubic centimeters is used for like solids and things like that, but they also use it in the medical industry. And if you recall, the other way to say that is 1 cc. And so here's just some densities, like we mentioned cork at first. Cork's 0.26. It's very, very light. But you come down, a diamond is very dense. So a lot of these aren't real surprises. Now, gasoline and olive oil and things like that, notice that they are less dense, and so we're not surprised that they float on water. Urine is pretty close to water at 1.0, as is blood. What makes it a little more dense is it has some things in it. Okay, so things that are dissolved in it make it heavier. That's why salt water would be more dense than just regular water. Your gases also have density, and they are measured in grams per milliliter here for you. So even gases have densities, and so all these materials that we've talked about, solids, liquids, and gases, these different states, all have various densities. Notice how light hydrogen is. Hydrogen's the lightest gas, and so it just floats off into the sunset. So when we're calculating the density of something, it's very similar to what we saw before. We state the given and the needed. We write the density expression. This is just a little bit different, and this is what we just saw. Density equals mass divided by volume. We express the mass in grams and the volume in either milliliters or cubic centimeters, and it totally doesn't matter because they're interchangeable. So the only thing other than this we might have to do is sometimes we may have to change it. Our units may have to change a little bit if our measurements are not in grams and milliliters. And then substitute mass and volume into the density expression and calculate the density. All right, so here's our first learning check with this. Osmium is a very dense metal. What is its density? Okay, so that's the question. In grams per cubic centimeter, if we know that 50 grams of osmium has a volume of 2.22 cubic centimeters. Now, this one's a little different because all we got to do is find out the density, which we know is mass over volume, in grams over cubic centimeters. Okay, so if you look at this, what are we being given here? We've been given 50 grams, and we've been given 2.22 cubic centimeters. So all we have to do is say density equals 50.0 grams of osmium per 2.22 cubic centimeters. Okay, and that is going to give us, all we have to do is put that in the calculator right quick, and that gives us 22, and it's going to give you 22.55225522 probably, but let's see if we get 22 point, how many significant figures are we going to have? 3 and 3, so we're going to have 22 point, is it 2 or 5? I have to look. It's 5, sorry. 22.5 grams over cubic centimeters, because that's the combined unit there of density. Okay, that one's pretty easy though, because all you had to do is just take those two numbers and divide them. So if we know how much something weighs and we know its volume, we can do this calculation. All right, so we have to have a way of figuring that out. So if we have a solid, then we don't know what its volume is very easily unless we can calculate if it's like a cube or a sphere or something like that, and there's a known calculation. But if it's some weird shape or whatever, there's a great method that we use called volume displacement. And volume displacement is kind of based on the same thing. Like if you fill your bathtub up too high and you get in it, what happens? Well, the water comes over, right? And you got a big mess. That's because the mass of your body displaced, well, the volume that your body takes up displaces the volume of water that was in the bathtub. And so by making room for your body, some of that water gets displaced and comes out. And so in the laboratory, what we do is we take the graduated cylinder and we fill it up and we make a measurement so we know exactly what it is. In this case, they did that with 35.5 milliliters. Then they put this bar in there, and when they put it in there, the level raised up to 45. Now they were very careful. This must be a 50 milliliter graduated cylinder. They were very careful to make sure that they had enough room, because if it came over where we had the markings, we wouldn't know how much that volume was. So we can look by displacement and tell that it was at 35.5. Once we put the metal in, it was 45. So the difference between those is the volume of that piece of metal there. And it comes out to be 9.5 milliliters or 9.5 cubic centimeters. So we got the volume. Now the only other part we need is the mass, and so that's very easy in the lab because we have some balances and we just put it on there and we can get the mass from that. And when they put this particular zinc bar on there, they got 68.60 grams as the mass. And so now, since we know the mass and the volume, we put 68.6 grams divided by 9.5 cubic centimeters, and when we divide those, we get 7.2 grams per cubic centimeter. Two significant figures because that was the lowest amount and we were dividing. Okay, here's your learning check. What is the density of a 48 gram sample of a metal if the level of the water in the graduated cylinder rises from 25 milliliters to 33 milliliters after you put it in there? Okay, so here's our visual. We had it at 25 milliliters. Then once we put the piece of metal in there, it rose to 33 milliliters. And so what we need to do first is find what that difference in volume is. So go ahead and try that and come back when you think you may have the answer. I'm going to give myself a little room here since you know how my handwriting is by now. Alright, so we already know that the mass is equal to 48.0 grams. And so our volume is going to be 33.0 minus 25.0. And that is going to equal 8, I think. Don't have my calculator out, so we're going to say 8.0 milliliters. Yes? Now, remember, since we were subtracting, it's the number of decimal places. That's why it's 8.0 in significant figures. All right, but the big deal is we know now that D equals M over V, and it can be M in grams and V in milliliters. So we've got 48.0 grams divided by 8.0 milliliters, and that is going to give us 6.0 grams per milliliter, or the same thing as 6.0 grams per cubic centimeter, because milliliters and cubic centimeters are the same. And so we would very strongly, confidently say answer 2 is correct. So this is the kind of thing that you may do on the test, and then you would say which of those answers was correct. Okay. I told you ice floats because it's less dense than water, and aluminum sinks because it's greater density than water. So this is not like a calculation thing. This is like, you look at this, and this is where we do our critical thinking. You've got Karo syrup, which is indicated by a K. Get my pen to work. Okay, its density is 1.4. You've got vegetable oil, V, which is 0.91, and you've got water, W, that's a 1.0. And so all you have to do is figure out which one of these pictures is correct. Okay, which one would be floating on top of which other one. So you can take a minute and think about it, and then you can turn me back on. Okay, so we know that V, I just kind of put them in order. V is 0.91. The next one, water, is 1.0. And then K, Karo syrup, is 1.4. And so the water is 1. Anything lighter will float. Anything more heavy, more dense, would sink. And so which one of those matches VWK? I believe it's going to be this one. Hope you agree. So you didn't even have to do any calculations for that one, those of you who don't like doing them. You just have to kind of look at it and use your brain. And there it is. So density, now that we can calculate density, we use density as an equality. And what it helps us do is to go from volume to mass, or from mass to volume in a problem. Okay? So, because again, it's an equality, because we know that D equals 3.8 grams per milliliter in this particular one. So that allows us to draw conversion factors. 3.8 grams over 1 milliliter, or 1 milliliter over 3.8 grams. And so we can use those in solving problems. And here's our old buddy, the guide to using density. You state the given and needed, you write the plan, you write whatever equalities you're going to use, and then you plug them in. Here's our learning check. The density of octane, a component of gasoline, is 0.702 grams per milliliter. What is the mass in kilograms of 875 milliliters of octane? Okay, so what can we hold in our hand? Although it'd be very stinky. Oh, I'll hesitate for a second in case you want to turn me off. What we can hold in our hand is 875 milliliters of octane. Okay? And we know the density of octane is what? Now, remember my rule. What goes on the bottom? Milliliters. That's right. So it's 0.702 grams per 1 milliliter is basically what that's saying. And it's octane, both of them. Okay, so we cancel that. And so we're at grams. Yay. Oh, no, we're not. It wants the answer in what? Kilograms. So we have to do one more thing, and I didn't hardly leave myself enough room, did I? What is a way to get from grams to kilograms? Grams is here, so it's got to go down here. So it's what? 1,000 grams per 1 kilogram. And that's going to cancel grams. And that's going to leave us with kilograms. And so that in my very messy, it's going to give me 0.614 kilograms. Wow, I got to use 3 significant figures that time. How come? Well, I had 3 there and 3 there. So I had the mass in kilograms of 875 milliliters of octane is 0.614 kilograms. Not much. And that's it. And congratulations, you have finished Chapter 1. I hope it wasn't too painful for you. We'll start Chapter 2 next, and I will be talking to you soon.